Morning, dear children. Welcome back to our online maths class. Okay, now we are doing the divisibility rules, isn't it? Yes. As I have been saying always, these divisibility rules are very, very important. So be thorough with it. I think we have done up to the rule of divisibility by 7 and its problem also, isn't it? Yes. Now let's start doing the question number 6. That is, check whether the given numbers are divisible by 9 or not. That's our question number 6. Please write down. Before start writing, mention date and day. Okay. Check whether the given numbers are divisible by 9 or not. Divisible by 9 or not. Okay, some numbers will be given. We have to check whether those numbers are divisible by 9 or not. What is the rule of divisibility by 9? Anyone remember? You should remember. What is the rule of divisibility by 9? Yes, same as that of 3, isn't it? Same as that of 3 means what is the rule of divisibility by 9? Yes, a given number is divisible by 9 if, yes, the sum of its digits is divisible by 9, isn't it? Same as the rule of divisibility by 3. A given number is divisible by 9 if the sum of its digits is divisible by sum of its digits is means sum. We are mentioning about the sum. That's why I have used is. The sum of its digits is divisible by 9, isn't it? Okay, let's try to do one by one. First number is, write down A. The number is 5886. 5886. So for checking whether this number is divisible by 9 or not, what we have to do? Yes, we have to find the sum of its digits, isn't it? I think 1 or 2 problem is enough in this, will be enough in this section, isn't it? Yes. Please find the sum. Sum of the digits. Sum of the digits is equal to, what is the sum here? 5 plus, yes, 8 plus 5 plus 8 plus 8 plus 6. What is it? 8 plus 8, 16. You can add as per your convenience. Let me add like this. 8 plus 8, 16. 16 plus 6. What is 16 plus 6? Yes, 22. 22 plus 5, 27. Okay. Is 27 divisible by 9 or is 27 in 9's table? Yes, isn't it? So what can we conclude? Yes. So since 27 is divisible by 9, the given number is also divisible, isn't it? Yes, please write down. Since 27 is divisible by 9, since 27 is divisible by 9, what can we conclude? Yes, 5887 is also divisible by 9, isn't it? 886 is also divisible by 9. Okay, it's 9. Okay, yes. Now let's try to do the second question. I think 2 questions is enough. 2 questions are enough. Okay, now let's do the second one, B. Try to do question number B. Okay. Write down the number. The number is 8091. 8091. Write down 8091 is the number. 8091, not 11. This is 1. 8091. How can we check whether it is divisible by 9 or not? 8091. How can we check? What we have to do? Yes, find the sum of the digits. Okay, try to do the answer. Sum of the digits is equal to sum of the digits. Sum of the digits is equal to, what is it? Find the sum. Which are the numbers to be added? 8 plus 0, no need, isn't it? Any number plus 0 is the number itself. 8 plus 9 plus 1. Can you find any easy way for adding this? Any easy grouping? Can you find any easy grouping here? Yes, of course. 9 plus 1, 10. 10 plus 8, 18. What is the sum? 18. Is 18 divisible by 9? Or is 18 and 9 stable? Yes, isn't it? 18 is in 9 stable. So what can we conclude from this? What can we conclude from this? Yes, since 18 is divisible by 9, the given number 8091 is also divisible by 9, isn't it? Yes, write down. Since 18 is divisible by 9, since 18 is divisible, 18 is divisible by 9, which is our given number? Yes, 8091 is also divisible by 9, is also divisible by 9. Okay? Yes. I think this much is enough in this section, isn't it? So let's try to do the homework of this session. You need one more? Okay, let's do one more. The next question is one easy one. Okay. 1008. Very, very easy. Question number C. 1008. In mind we can do, isn't it? The number is 1008. Is it divisible by 9? Yes. 1 plus 8, 9. Surely. Okay. Okay. Answer. Sum of the digits equal to sum of the digits equal to, in mind itself we can do, isn't it? 1 plus 8 equal to 9. So what is the conclusion? Is 9 divisible by 9? Surely. So what can we conclude? Since 9 is divisible by 9, or so without that step we can write 1008 is so 1008 is divisible by 9. That's enough. Here 9 itself, isn't it? So 1008 is divisible by 9, isn't it? You see how easy this method is. Otherwise, how can we cancel? If in a fraction, in the numerator 1008 is there and in the denominator 9 is there, without knowing this, or sorry, in the numerator if 1008 is there and in the denominator the number somewhat 27 is there in the denominator. So of course we know 9 is a factor of, we can divide 27 by 9, but how we know, how can we understand that the number 1008 can be divided by 9 without knowing this rule? How can we realize that? Here lies the significance or importance of these divisibility rules. Understood? Okay, yes. Now let's note down the homeworks of this session. D and E are homeworks. D and E are homeworks. D. Note down the number D. D, the question is 4,869. 4,869. Homework E 882. Two homeworks are there in this section. Okay. Then in this session, two homeworks are there. Next, let's try to do the rule of divisibility by 11. Before that, we have 10. What is the rule of divisibility by 10? What is the rule of divisibility by 10? Question number 7, I think. What is the rule of divisibility by 10? Yes, a given number is divisible by 10 if its last digit is 0. That's all, isn't it? So, question number 7. Encircle the numbers. Encircle the numbers. Encircle the numbers which are encircle the numbers which are divisible by 10. Which are divisible by 10. Okay, the given numbers are 8,13,990. This is the first number. Second number, 4,21,815. Third number, 1,01,000,001. 1,01,000,001. And finally we have 39,18,310. These are the given numbers. Okay. For reading the numbers, better to put the commas properly. Otherwise, it will be confused. A little bit confused. Okay. Now, among these, which are the numbers divisible by 10? Let's consider the first number. For checking whether a given number is divisible by 10 or not, we need to consider the last digit only, isn't it? Isn't it? If the last digit is 0, we can say that the given number is divisible by 10. So here, which is the last digit? 0. So is it divisible by 10 or not? Yes. So encircle this. Understood? Here, which is the last digit? 5. So is it divisible by 10? No. Here, which is the last digit? Many zeros are there in between. But is it divisible by 10? No. Why? The last digit here is 1, not 0. So this is not divisible by 10. What about this number? 39,18,310. Last digit here 0. Is it divisible by 10 then? Is the number 39,18,310 divisible by 10? Yes. Okay. Yes. Good. Now try to do the problem of divisibility by 11. Do you remember the rule of divisibility by 11? Anyone? What is the rule of divisibility by 11? 11. What is the rule of divisibility by 11? 11. What is the rule of divisibility by 11? Yes. We have to divide the numbers, classify the numbers are digits on odd places and digits on even places. Okay. Don't write, just listen. First, start from the last number digit, odd place, even place, odd place, even place, odd place, even place, like that. We have to classify the numbers. Then find out the sum of the digits on odd places. Isn't it? Sum of the digits on odd places has to be found. Then sum of the digits on even places has to be found. Then the difference. If the difference is either 0 or divisible by 11, 11, we can say that the given number is divisible by 11, isn't it? That is the rule. Okay, let's try to do. Question number 8 and last question of this session. Last question of this session. Question number 8. Write down, check whether the given numbers are, check whether the given numbers are check whether the given numbers are divisible by, check whether the given numbers are divisible by 11 or not. Divisible by 11 or not. Okay, let's discuss one by one. Question number A. 2475. A, the question is 2475. 2475. How can we check whether it is divisible by 11 or not? Sorry, let me write. It's not working sometimes, that's why. Okay. 2475. Okay. What we have to do for this? For checking whether it is divisible by 11 or not, what we have to do? Yes, we have to classify the digits as digits on odd places and digits on even places. So let's start from the last digit. First digit, odd place. Second one, even place, E. This is not O. Second one is E. Okay. Second one is E. Even places. Then 4 is odd places. Don't think 4 is an even number, then ma'am is writing over there. Don't think like that. I am mentioning about the place. Odd place, even place, like that. Add 2, even place, isn't it? Now, next what we have to do in the answer? What has to be done? Yes, sum of the digits on odd places minus sum of the digits on even places. Or separately we can do. Sum of the digits on odd places. Find out please. Sum of the digits on sum of the digits on odd places equal to, what is it? 4 plus 5 is equal to 9, isn't it? Okay, next we have to find sum of the digits on even places. Sum of the digits on even places. Sum of the digits on even places. Okay, sum of the digits on even places. What is it? Which are the digits on even places? Please check your question. Okay, it's 2 plus 7. Okay, 7 plus 2, and that's also equal to what? Yes, that's also equal to 9, isn't it? That's also equal to 9. So, next step is what? Their difference. We have to find out the difference of the sum of the digits on odd places and sum of the digits on even places. Let's find out the difference. Okay. Their difference. That's enough. Their difference is equal to. Their difference is equal to, what is it? 9 minus 9 equal to 0. So what from this, what can we conclude? Since the difference is 0, we can say that the given number is divisible by 11, isn't it? Understood? The condition is the difference should be either 0 or divisible by 11. Here it is 0. So what can we conclude? Since the difference is 0, the given number is divisible by 11. Okay? Yes, write down. Since the difference is since the difference is 0, which is our given number? Yes, 2475 is divisible by 11. 75 is divisible by 11. 2475 is divisible by 11. Please write down, okay. 2475, sometimes it doesn't work. 75 is, let me write down, then how it will be, let's check. 2475 is divisible by 11, isn't it? Okay. Now let's try to do one more. So classify the digits as digits on even places and digits on odd places. Find the sum and their difference. For some of the digits on odd places minus some of the digits on even places, the difference has to be found. Then if the difference is either 0 or divisible by 11, we can say that the given number is divisible by 11. Okay. Now let's try to do the next one. Second question, 4917. Question number B, 4917. 4917. So classify the digits as odd and even, isn't it? First one odd, then even, then odd, then even. Then what we have to do? Find the sum of the digits on odd places, isn't it? Sum of the digits on odd places. What is it? Which are the digits on odd places here? 7 and 9. Please find the sum. 7 plus 9. What is it? 7 plus 9. What is 7 plus 9? Yes, it is 16. Okay. Now, then what we have to do? Find the sum of the digits of even places. Okay. Sum of the digits on even places is equal to what? Which are the digits on even places? 4 and 1. So 1 plus 4 equal to 5. Next, what we have to find? Yes, their difference, isn't it? Their difference is equal to, what is the difference? Their difference is equal to, what is it? 16 minus 5. What is 16 minus 5? 11, isn't it? Is 11 divisible by 11? Surely, isn't it? 11 is divisible by 11. So what can we conclude? Since 11 is divisible by 11, the given number 4917 is also divisible by 11. Isn't it? Understood? Okay, yes, please write down. So, please write down, since 11 is divisible by 11, since a number is divisible by itself, isn't it? 11 is divisible by 11. Which is our given number? Yes, 4917 is also divisible by 11. Okay. Sometimes my pen doesn't work properly. That's why I'm writing like this. You should write neatly. Okay. Okay. Let's try to do the third problem. See, the question is 10,131. 10,131. See, the question is, have you understood the method? Classify the digits as digits on odd places and digits on even places. Then find the sum of the digits on even places, odd places. Then find the sum of the digits on even places. Find out the difference. If the difference is either 0 or divisible by 11, we can say that the given number is also divisible by 11. Okay. So next, see, the question is 10,131. Here also classify the digits as odd and even, isn't it? Odd place, even place, odd place, even place, odd place. Okay. Now what is the next step? Which is our next step? Find the sum of the digits on odd places, isn't it? Okay. Answer. Sum of the digits on odd places is equal to, what is it? 1 plus 1 plus 1. That's equal to 3, isn't it? And next we have to find out, yes, the sum of the digits of even places. Sum of the digits on even places is equal to, what is it? Which are the digits on even places? 3 and 0, isn't it? 3 plus 0 is equal to 3. Next step is what? Finding out their difference. Okay. Their difference is equal to their difference is equal to, what is it? 3 minus 3 is equal to 0. So what can we conclude? Since the difference is 0, the given number is divisible by 11, isn't it? Yes. Write down. Is it clear now? Any doubt? If you have any doubt, you can WhatsApp your doubts to me. Okay, no, don't worry about that. I am ready to answer. Okay. Since the difference is 0, since the difference is 0, the given number, or what is our given number? 10,131. 10,131 is divisible by 11, isn't it? Either the difference is 0 or divisible by 11. We can say that the given number is also divisible by 11, isn't it? Yes. Okay. Now let's try to do one more. One more will be enough. 9,348. Have you done that? No. Isn't it? D. The question is 9,348. 9,348. D. 9,348. Okay, before start doing the answer, which is our first step? Classify the numbers as digits as odd place and even place. Okay, first one odd place, second one even place, then odd place, then even place. Okay, sum of the digits on odd places, sum of the digits on odd places. What is it? Which are the digits on odd places? 8 and 3. So 8 plus 3 is equal to 11. Okay. Then we have to find out sum of the digits on even places, isn't it? Okay. Sum of the digits on even places. Sum of the digits on even places has to be found. Okay. That's equal to, the number is 9348. Which are the digits on even places here? 4 and 9. Okay. 4 and 9. That's equal to, which is it? 9 plus 4. What is it? 13. And next step, the difference. Okay. Sum of the digits on odd places we obtained as 11. Okay. 8 plus 3, 11. And sum of the digits on even places is 9 plus 4, 13. And next step is find out their difference, isn't it? Their difference is equal to their difference is equal to, what is it, 13. We have to subtract the smaller from the greater. That is enough. That is the convenient way, isn't it? 13 minus 11. 2. Is it 0? Is 2 0? No. Is 2 divisible by 11? No. So what can we conclude? So the given number is not divisible by 11. Understood? Clear? Okay. So given number is, which is our given number? Better to write that. Which is our given number? 9348 is not divisible by 11. Understood? Here our difference is 2. 2 is 2 0? Is 2 equal to 0? No. Is 2 divisible by 11? No. Both the conditions are not satisfied. So we can say that the given number is not divisible by 11. Understood? So let's note down the homeworks of this session. The homeworks are, note down the homeworks. Homeworks are E 6182. That's homework. EF 7282. Try to do the homeworks. Learn it well. Thank you. Have a nice day. Okay. Yes.